Number one, we have a mini chart. Number two, we have range chart. Then number three, we have proportion chart. Those are three charts they can ask under control charts. Mini chart is the same as X bar chart, X with bar. X bar chart. They ask you X bar chart, you know that they have asked you mini chart. Range chart, they can say you construct other chart. Then proportion chart, they can say you construct P chart. For every chart, you realize that we are going to be getting the average. If it's mean, you get average mean. If it's range, you get average range. If it's proportion, you get average proportion. So that is number one. Then number two, if it's, let me just say mean, let me just say average, then you also look for upper control limit. For every chart, we look at average, we look at upper control limit, then we also look at lower control limit for every chart. Whether you're doing mean chart, range chart, or proportion chart, you must have these three items. We must see lines in the line indicating average. We must see the line indicating upper control limit. You must see the line indicating lower control limit. Why? Why do you need this? This is control chart. Control chart, you'll find that it is going to help you to know whether control chart helps us to know whether we whether the process, it could be to know whether the process can be the production process. It can be any process. To know whether the process is in a control. Control chart helps us to know whether the process, it can be the production, it can be the sales, any process you're talking about, you're testing. Know whether that process is in a control. So for you to know whether the process is in a control, then it means that you need upper limit, you need also the lower limit. If you plot your mean, if you plot your average, if you plot your proportion, you see whether all points are within the control. We don't want to see a point exceeding upper control limit. We don't want to see a point that is below lower control limit. If you realize that you have a point that is above upper control limit, then obviously it will be an indication that the process is not in control. If you plot and you realize that you have mean, which is below, you have 1 point, which is below lower control limit, it will be an indication that the process is not in control. So basically that's about control chart. For every chart, you will need all this. Okay, so without wasting time, we are going to look at some questions, past paper questions. Number one, you can check December 2022. This is question 4C. Then number two, you can look at model paper 2023, question 5A. Then you have, this one talks about P chart. Then this one talks about mini chart. Then We also have September 2022 at question 3C. This one talks about range chart. Then we have December 2021, 3B. This one talks about range also. Sure. Yeah, range. Then we have now next question, October 2021, question 3B. This one talks about mean. Then you have June 2022, question 5C, and it talks about mean and range. Okay. So these are some of the questions, past paper questions. It's a very common area, but it is not hard. Okay. I think I'm going to share to those who don't have. But as I said, just this is the graph that is going to help us to study how the process changes over time. And it has a central line. A central line will be indicating the average, as I said. And you have the upper line indicating the upper control limit. You have also the lower line indicating the lower control limit. Those are three components I was talking about. So when you're reading this handout, don't be confused. Then what else? When are you supposed to use control chart? These ones you read through. Just what I need is I need how you interpret the table. Now with control charts, you will be interested in knowing what is your sample, what is your observation. If you cannot differentiate the two, then it can be hard for you. You need to know from the information given, you as the data analyst or you as the decision maker, what is your focus? What are you observing? Or if you're a data collector, what are you actually observing? Okay, from your samples, what are you collecting? What are you observing? So you need to know what is the sample, what is the observation. The examiner will not, sometimes the examiner will not be clear. Now, in an exam, if you're given a table, you need to know how you can read the table. You need to know how you can read the table. And your n, this n will always be the number of observations. This n, number of observations. You see in an exam, in a question, how many observations do you have? If there are 5, you stand where you have 5. You look for the unknown. Unknown could be, let's say, A. It could be D3. It could be D4. The unknowns. You find that we are going to see that you will be in your formula, you will need A2, you need D3, you will need D4, depending on the question. Okay. So if number of observations are, let's say 9, let's say 6, you stand where you have 6 and read A. A will be this, D will be 0, D3 will be 0, D4 will be this. So that's how you'll be reading the table. Okay. Now, here he tried to explain what is N, stands for number of observations in the sample. Okay. Then as we use mean and range charts, you will be finding that in your formula, as you get your upper control limit or lower control limit, you are using this. You are using either A2 in your formula or D3 or D4. And these are the formulas. You have the formulas for range. we'll be looking at each sample. We'll be looking at each sample. You'll find that as you plot your range chart, you're plotting range against sample. So if you have 10 samples, it means that each sample will be having a range, will be having a range figure. So the range you're talking about here looks at each sample. And how do you get range? You get the highest value minus the lowest value from the data. From each sample, you will observe different values. Like, let's say here, for example, this is the question. You are given service response durations, you are given days. So the question will be, from this, what is your sample? What is your observation? What are you observing? You are observing service response duration for each day. Each day you're observing how staffs respond. Each day you're observing how staffs respond. Okay? So the days are your samples. You have 10 samples. So each sample you are observing how many times. In a day, you are observing how many? 1, 2, 3, 4, 5. You're observing 5 times. So the total number, the total N is 5. So from what you're observing, what is range? What is range for this sample? What is range for this sample? Highest minus lowest. That's how you'll be getting range for each sample. Highest minus lowest. Highest minus lowest for each sample. Then if you're looking for mean, you get all the values, then you divide by the number, then the total number. How many items have you added? So you get this plus this plus this plus this plus this, then divided by the number, by 6. By 6, 5, by 5. Okay, that's how you get mean. So that's how you need to know what is your sample, what is your observation. So that's what I was trying to explain here. Each sample you look for range. Each sample. Then mean, then after getting range, you'll find that you have to go ahead and get mean of range, as we are going to see. Okay, then when you're getting upper control limit for range, this is the formula you will use. You have to take note. Sometimes in an exam, you're given this formula. You find that the examiner has given you the formula in an exam. So you see this D4 is constant. D4 is a constant value. An examiner will give you D4, or he can give you the table so that you can get D4. Like he can give you this table to use it to get D4. You know your total observation 5. If it is total observation, if your total observations are 5, then D4 will be this one. Okay. Then R bar, this is average range. Average range, you will get your total range for all samples. Total range for all samples divided by N. Colleagues, are we together?
Yes.
Okay. So that's how you will be getting your upper control limit. Also lower control limit, this is the formula. The R bar remain the same, but what changes is D3. So upper limit, you're using D4. Lower limit, you're using D3. Okay, that's all about range. That's all about range. So as we compute range, upper limit and lower control limit, these formulas will be very, very key. Okay. So we have also mean for each sample. As I said, you get total of all observed values in a sample divided by number of observations. Like what we are meaning is that add all these values, then divide by number of observations. 1, 2, 3, 4, 5. Okay, that's how you'll be getting the mean of each sample. Mean of each sample. You have 10 samples. So what is this? What is sample mean for day 1? What is sample mean for day 2? What is mean for day 3? You'll be getting for each. Then how will you be getting the upper control limit for mean? Upper control limit for mean will be this. You use this formula. Very, very key. This is mean with, this is X with 2 bars. What does this one mean is mean of means. Mean of means, you first get mean. After getting mean, you go ahead and get the mean, the overall mean. Like you have mean for each sample here. You have mean for day 1, you have mean for day 2, you have mean for day 3, you have mean for day 4, up to day 10. But we need only one mean. That mean you will get is called the mean of means. You're adding means to get one mean. That is mean of means. So you'll be adding all means, then you divide by the number. That is the formula of mean of means. This looks at average mean for all samples. You add all means, then you divide by the number of means you have added. Okay, so and that's all. These are the only things you need to clear this area. To clear this area, only these ones. Someone is saying it's December 2021. Yeah. Okay. This question 1, it's December. Someone is saying it's December 2021. Question 3B. Colleagues, we are here. December 2021. Required part, they are telling us we calculate the upper control limit and lower control limit. Now, at this point, you don't know whether you are dealing with mean or range. Colleagues, it is very, very key. It's very, very key to know whether you're dealing with mean or range, or whether you're dealing with both. So it's upper control limit and lower control limit for deregulation range. Examiner has specified that this is range. Okay? Examiner has specified that this is range. So what does this one mean? It means that you don't need to focus on mean anywhere. And they have, the examiner has said you calculate. You don't need to plot. You simply calculate. So they are telling us that customer service response duration in minutes for 5 staff at a call center of Yugatel for 10 days period was recorded in the table below. Colleagues always know, you are the person who is recording data, or you are the person who is observing, who is making the observation. What is your focus? What are you actually recording? What are you actually observing? You are observing the customer service response duration. These are staffs at a call center. Customers normally call with maybe their complaints, maybe as seeking for advice or for help. So you are trying to observe these staffs take how long to respond a customer. And you see that day 1, the first staff takes this, the second staff takes this, third staff takes this, first, like that, okay? This is what you're observing. So from this information, can you get range for each sample? It means that you have, out of all many days we have, you have sampled only 10 days. your focus is on only 10 days, you're on only 10 days. So it means that you need range for each day. So what you're going to do, to get range, we are saying get the highest value minus lowest value. That's how you get range. From your data, from this data, day one, this is day one, sample one. What is highest value from what you have observed? What is the highest value? Get that highest value, then subtract the lowest value. So what is our highest value? So yeah, examiner is testing your attention to detail.
Highest value on row 1, right?
Yes.
11.7.
Yes. So you get that 11.7 minus lowest value is what?
Is 6.7.
So that's what you're going to do. You come here, you get 11 point, it was 11 point what? 11
7
minus
minus 6.7.
0.7. That will be your range. Then for day 2, for sample 2, you also do the same. Highest minus lowest. What is the highest value here?
11.4.
You get 11.4 minus what?
7.6.
7.6. You must be very attentive. Otherwise, you just move out of the paper saying you passed, you copied the wrong figure. So the lowest value is 7.6. And as I said, if you observe that, then that number is your savior. Pay attention to it. So that's how you'll be getting range for each sample. Highest minus lowest for each sample. Okay. In this question, we are only focusing on range. Now, assume the question was about mean. How do you get mean? How do you get mean? How do you get mean? You sum up, you get all the values for day one, all these values, add all of them, divide by how many? 1, 2, 3, 4, 5. You divide by 5. So what do you get? You get this plus this plus this. You can open bracket, you say open bracket, this plus this plus this plus this plus this. The answer you get close bracket. Okay, open bracket, this plus this plus this plus this plus this, close bracket. Then divide by 5. What do you get? Colleagues, what do you get?
I get 8.856, but the rest of the team can confirm.
8 point what?
8.856.
Okay. That's all of you have this? Then next you do the same. You do the same for the next. Which screen are you seeing?
The one that has the question.
Okay, so you still add. You add and you add from here up to here. Open bracket, this plus this plus this plus this plus this, the answer. Then close bracket, divide by 5. Open bracket, this plus this plus this plus this plus this. Answer before you click on equal sign, you first close. Open bracket, this plus this plus this plus this plus this, close bracket, then divide by 5. What do you get? What do you get?
9.12. But
Pardon?
I'm hoping that 9.12, I'm hoping that my colleagues too can cross-check so we are on the right track.
So this is how we get mean.
Yes.
Total observation divided by number of observations. So once you do that, go ahead and get the total. What is the total? You add all. Are you in a position to see my screen?
Yes.
So you add, that is total range. If you're focusing on mean, you'd also do the same, you add. Okay. So the question is, we calculate or we compute the upper control limit for range. And you saw that from our formula, the upper control limit for range, even the examiner, December 2020, that paper, December 2021, examiner gave you the formula. That the upper control limit is D4 times average range, R bar. That is the formula. Then lower control limit is D3 times average range. So you have the formulas where D3 is given and D4 is also given. D3 is 0, then D4 is 2.114. Okay?
Okay.
So we can now remember let me hope you're writing. Upper control limit for range. The formula is this. Where R bar is average range, or what we call mean of range, and mean of range is equal to total range for all samples. What is this total range for all samples? This is the total range for all samples, this one. Because this is range for each sample. This is range for for sample 1, for sample 2, for sample 3. But here we are saying get total range for all samples. Then divide by the number of samples. How many samples? 10. Okay, that's how you'll be getting R bar. Are we clear about R bar? Then D4 is given in the question. So finally, go ahead and get upper control limit for range. You get D4 times the R bar, and this is our upper control limit. You can round off to at 2 decimal points even. You can even round off to 2 decimal points or 3 decimal points. Any question here? Is everything okay? So you can also go ahead and get the lower control limit. Examiner said you compute the upper control limit and the lower control limit. So the lower control limit, the formula is you get D3 times the average range. And D3 is what? D3 is 0. Examiner said that D3 is equal to 0. So where you have D3, you put 0. Where you have D3, you put 0. Average range, already you have the average range from here. So you get 0 times 3.68, which is 0. So upper control limit is, rather lower control limit is 0. Examiner said you go ahead and comment. Go ahead and comment on your observation. Comment on your observation. How do you comment? How do you comment? How do you comment? To comment, you are going to look at your upper control limit. This is your upper control limit, this one, and this is your lower control limit. Then ask yourself, Are all your range values for each sample? Are all range values for each sample within the limit or not? Like you come back to your table, to your table here. These are range values. You ask yourself, do you have a range figure that is above upper control limit? Remember, upper control limit is what? 7.78. This is upper control limit, 7.78. Do you have a figure that is above 7.78? No. We don't have a figure that is above 7.78. Then also ask yourself, do you have a figure that is below the lower control limit? Lower control limit is 0. So do you have a figure that is below 0? We don't have a figure that is below 0. So this implies that our process is in control. So the comment you put, you say that the process is in control since all range values, for each sample, fall within the control limits. The control limits are upper limit and lower control limit. Is this clear? And you're done. 7 marks. You're done. That was about that question. This one was not all that key, but for purposes of discussion, I included it. So in an exam, you're supposed to just come up with this, then write this, and stop here. You earn your 7 marks. Now assume the question. Assume examiner wanted. Assume it was. Assume upper control limit for me and lower control limit for me. How do you get upper control? How do you get upper control limit for mean and lower control limit for mean? Assume examiner said that you calculate the upper control limit for mean and the lower control limit for mean. How do you get that? Okay, it means now, colleagues, once examiner has indicated that you get mean, it's a must. It's a must to also include this column. It's a must. Why? Because in the formula for upper control limit and lower control limit for mean, you will need average range. So it's a must. It's a must to create this column when you're dealing with mean control limits. So how do we get the upper control limit for mean? How do we get the upper control limit for mean? We have the formula, upper control limit for mean. We have the formula from our handout. This is upper control limit for mean. This is the formula. This is the formula. Let's first get mean of means. Coming back at here. How do we get mean of means? Mean of means, that is x with 2 bars, mean of means. You get total mean of all samples. You have mean for each sample. This is mean, you have mean for each sample. So get total mean. Total mean is this for all samples. Total mean for all samples is this. Okay, 93. It's this one. Then you divide by the number of samples, 10. What do you get? You get 9.3. So that will be your X bar. X with 2 bars, mean of means. Then how do you get A2? How do you get A2? Assume examiner has given you the table. Assume examiner has given you the table. You go to your table. You go to your table and look for where A2 is. This is A2. This is A2. And how many observations do we have in this question? How many observations do we have in this question?
10.
10.
No. We don't have.
No, 5. There were 5.
We have 10 samples, but we have 10 samples with only 5 observations. In each sample, you're observing only 5 times. So once you see in an exam, if you confuse this, then you will not get it right. N is number of observation, not number of samples. Total number of observations, 5. So you stand where you have 5, move horizontally, look for A2. A2 is this. Oh. A2 is 0.577. Okay. That's how you get A2. That's how you get A2. Then average range, already we have the average range. So I don't need to compute the average range. Average range is from your range, you had your total range, then from there you had to go ahead and compute the average range. Total range of all for all samples divided by number of samples. So this is the average range, mean of range. So you substitute in the formula now. Here we are substituting in the formula for upper control limit. Upper control limit for mean. Where you have x2 with 2 bars, you put 9.3, this one. Then plus, open bracket, A2 is 0.577 times average range, which is this. So that is your upper control limit. Then lower control limit, it's the same, just that with lower control limit, where you have positive, you put negative. Same formula, but the difference is only here. Okay. So that's how we get the upper limit and lower limit. That's how we get the upper limit and lower limit. To comment, you still use the same idea. Look at your upper limit and lower limit. Go back at your table. This is the upper limit for mean 11.4. Come back at your table. Ask yourself, do you have a figure that is above 11.4? We don't have a figure that is above 11.4. Then also ask yourself, do you have a figure that is below 7.17? Do you have a figure that is below this? Let me see. All our means are above 7.17. So it means that the process is in control. The process is within the control. If you realize that you have 1 point or one figure that is above or that is below, automatically it will be an indication that the process is not in control. So the comment will be, the process is not in control since there is a value that is outside or that is not within the limit. Any question about how we get upper control limit? here you are told to calculate the control limits for range and mean charts. What does this one mean? It means that you need to calculate, you need to look for upper control limit for range, lower control limit for range. After that, you go ahead and look for upper control limit for mean, then also look for lower control limit for mean. 10 marks. Okay. Is this hard? Is this hard real?
No, it's not.
June 2022. So all you need is to put your sample here. We are answering part A. This was part A. Oh, let me see. This is part C Roman 1. Part C Roman 1. So you put here sample, then you put here mean, rather range, start with range, then you create column 4 for mean. How many samples do we have in this question? How many samples? We have only 5. Okay. This is sample 1, 2, 3, 4, 5. So you can get range, highest minus lowest. You do the very first. Everyone can get. Like one can handle last row.
I am doing number 5. Abel, on 5, the mean is 604.
The mean or range?
The mean. I went for mean first, sorry.
It's what?
604 on 5.
6.5.
No, there's
Okay.
no 0.5. 604 just, no 0.5. Yes, like that.
Colleagues, you can also, you are doing.
Kindly share the question again so we can do the numbers.
Remember to get mean, meaning you're adding all these values, then divide by 4. This plus this plus this plus this, the answer you get divided by 4. Then range, you're getting the highest minus lowest.
Abel, the range on number 5?
Number 5 is what?
Which is 614 minus 590 is 24.
24.
Number 1
Other
is
colleagues,
24.
where are you?
Number 1 is 24. Number 2 is 10.
10.
Yes. Number 3 is 22.
22.
Number 4 is 32.
That's it. Yeah. What about mean?
Let me calculate. $601.
600, 601. Next.
597. $602.
602.
$582.
This is 582. 582. But
And
are
4
you
is
getting
602.
Sorry?
On 4, it's 602. The one that is missing.
602? Are you all
Yes.
getting the same answer?
Yes.
Okay, so from here you get your total. You add. Then also here you add. That is the total.
The total on mean? Yes, it's 2. Yeah, they are correct.
So from here, you need to get upper control limit for range. Upper control limit for range. Using this formula, upper control limit for range will be equal to that. You have D4. D4 here is what? D4 is, it's given in the question. D4, it was given as what?
Wait, I don't see it in the question.
It was given in the formula sheet.
Okay.
It is given here.
D4 is 2.282.
This is given here. Okay. So that is your D4. Then how do you get R bar? This is our average range. Average range. We follow this. We follow this formula. Average range. Average range is equal to that. That is mean of range. The average range. Total range of all samples divided by number of samples. This will be equal to what? Average range. You get the total range. Total range is this one. So you get 112. Then divide by
5. The 5
by
samples.
what is number of samples? How many? 5. So what do you get?
22.4.
Divided by 5. You get 22.5. So from here, you'll be in a position to get upper. You'll be in a position to get upper control limit. So upper control limit will be equal to. It will be 2.282 times 22.4. What do you get? 22.282 times this. Do you have 51.1?
Yes, we have 51.1. Maybe does the number of decimal places also matter here?
They are not much, but I encourage, if you realize that it's about plotting, round off to the whole number to avoid issues. You know, plotting when you have decimal points, there is a lot of problem.
Okay.
So when you realize that the examiner said you plot, avoid the decimal points, or you round off to 1 decimal point. like 51.1.
Okay, thank you.
Okay. So how do we get lower limit? Now we are done with upper limit. Let's get lower limit. Lower limit for range. The formula is here. Lower limit for range. That is the formula. That is the formula. D3 times average range. So D3 is what? Is 0 times average range, which is 22.4. And our answer
Is
is 0. You're done. So go to mean. Mean, the formula is given. We need the upper. Let me just copy this, all of this. Okay. You recall the formula we use. Actually, even in an examiner gave you the formula. This is the formula, mean control limits. This is the formula, X bar minus O plus. Just, it's you to know that when you're dealing with upper control limit, you use a plus. Lower control limit, you use a minus. But this is the formula. A2 is given. So let's get X bar, mean of means. Mean of means, you get total mean of all samples divided by number of samples. So this will be equal to, what is the total sample? Rather, total mean. Total mean is this. Divided by number of samples, divided by 5. So what do you get? Get this divided by 5.
598.2.
Colleagues, are you following? That is mean of means. From here, from your mean of means, go ahead and get the upper control limit. Upper control limit will be equal to upper control limit. Let me just remove this because it's kind of upper control limit will be equal to you follow the formula. You have a mean of means, which is 598.2. Okay, then plus, what is A2?
A2 is 0.729.
A2 is this one, 0.7229. That is A2. Then times zero, R average range. What is your average range? 22.4. It's good to put these ones in a bracket so that you don't make error. So on your calculator, what do you get?
614.53.
614.53.
53.
Okay. Then you do the same for lower limit. Lower limit, I just copy everything. I just change some things. Where there is a plus, I put a minus. Here you will put the word lower limit. Lower limit for me will be, this is lower. Will be here, I put minus. So what do you get?
581. 0.87. Okay, 0.9. I don't.
Okay, so we have everything, and that's all with part A. That's all about Roman 1. That's all about Roman 1. So from Roman 1, is the process in control or not? Using your mean or using your let's say using range. Is the process within the control or not? Using range, is the process in control or not?
It is in control.
Upper limit is 51. Come back at your range and see whether you have.
Beyond the limit.
Okay, okay, it is within the control. Then when you look at mean, is it also within the control?
Yes. Yes, it is.
So you see, using both parameters, mean and range, you see that the process is in control. Then Roman 2, they are saying what? Roman 2, they are saying, back at our question. After this data was collected, a new batch of workers were employed, which created a need to recheck the process again. Another sample result readings this. Now you have another sample with these readings. Okay, so you determine, remember they are saying you determine whether the production process is still in a control. So you have another sample. Whenever you have a sample, you must look for range or look for mean. You get? So let's look for range for this sample. Range for this sample. What is range for this sample? What's range for this sample? What's range? This is like range for sample 11. No. For sample what? We had only 5 samples. So this is for sample 6, which will be equal to highest
minus the lowest.
And
our
this
highest
is what? What is the highest?
623. And the lowest 570.
And you get what?
You get 53.
53. Okay. Now, to know whether the process is still within the control, I need my new upper control limit for range. I need my new lower control limit for range. Remember, you get D here, it is D what? D4 times average range. D4 times R. Average range. Then here, it's what? It's
so that's R bar, right?
Yeah.
D4 times R bar.
Yeah. Let me just times average range. Okay. So how do you get the average range? new average range, R bar is equal to, already you have the total. You have the total for 5 samples.
Of
isn't it?
112 plus the 53, the new one, and we
You get
divide by
that one?
6.
You get 112 plus
The
53.
53,
Now you
since now
divide
there
by
are
what?
6,
You divide
by
by
6.
You divide by 6. What do you get?
You get 27.5.
27.5. That is your average. So
Yes.
from the average, can you get the new upper control limit? Where you have average, put that.
20.8.
So D4 is what? D4 is what? 2 point what? 2.282 times 27.5. What do you get?
Get 62.755.
62.7.8. Then your new lower control limit for range is equal to what? Is 0. It's D3, which is 0 times the average range 27.5. And you get 0. So the question is the process still within the control? Is the process still within the control? Are all the figures within the limit?
Yes.
No.
Because we have a new upper control limit of 62.8,
Oh,
I
okay.
think it's still within control.
So
Based
you
on
see
the new
all range values.
Control.
All range values are within the limit, isn't it? Are within the.
Yes.
There is no figure below lower control limit. There is no figure above upper control limit. This implies that the process is still within
The limit.
This implies that the process is still in a control. And the colleagues, that's all with that question. You don't need to test another using mean. No, just use one like range. Range is enough. You just say using range parameter. Using range. If you want to test using mean, then you test using mean. Okay. So colleagues, that's all for this question. Let's have a break of 10 minutes, then we continue.
Thank you, Abel.
A break of 10 minutes. I'm not saying you sleep. Which year is open? Which question paper?
October 2021.
Okay. October 2021, part B. This is question 3, part B. You are told to compute the mean of means. Mean of means, you are looking at the overall mean. You are looking, remember you get mean for each sample. After getting mean for each sample, you go ahead and get the overall mean. That is the mean of means. The same applies to mean of range, the mean of range. You first get range for each sample. After getting range for each sample, just get one range. By getting total range, divided by the number of samples. Here you get total mean divided by number of samples. And you see, good thing here, you're given, even the examiner helped you. You have a mean column, you have also range column. Examiner wanted people to pass. Here you simply, to get mean of means, you simply add this plus this plus this plus this plus this. The answer you get divided by how many? By 5. And that is mean of means. Range, add this plus this plus this plus this. The answer you get divided by 5. And that's always Roman 1. Roman 2, the same concept. Determine the upper and lower control limit of mean and range. So you have to look at it separately. So I think that one now you can clear it, isn't it? Isn't it, colleagues?
Yes, we can try.
Yes.
Let me also, that one is now, let me close it, okay. Then we have another one here. Are you seeing September 2022? Which screen are you
Yes,
seeing? September 2022.
September 2022, yes.
September 2022. Question 3 parts. Are you seeing what you're given? They are telling us that the following data was extracted from the notebook of an intern student in a project planning department of Proud Enterprise. You have mean of samples. Now here you're given mean direct. You're given mean direct, mean for each sample. You're also given range for each sample. Range for each sample. You see how examiner always want people to pass? Given that A2 is this, D2 is this, D3 is this, then D4 is this. You have mean controls, the formula is here. You have range control, the formula is also given. Determine the upper and lower control limits for the mean and range. Can you feel this? Can you feel this?
No.
Here, the first step you will need to do is always first to get the average range. It can save you. How do you get average range? You add these ones, then divide by the number of samples. You get 23 plus 39 plus 14 plus 5, like that. Then the answer you get divided by 10. First get average range. Once you have your average range, then you can easily be in a position to get. Actually, it is good first to get average range and average mean. That is mean of range and mean of means. Once you have those two, it can be easier for you to get upper limit and lower control limit for mean and range. Here they are telling us that we do what? So, colleagues, let's do this. Let's do this actually. This is what I want. Let's do this. Let's do this. This is September. This is September 2020. What? 2022. Question
Yes.
3. Question 3 part C. Question 3 part C. Which screen are you seeing?
Excel.
So we have, we are told the part A, we determine upper and lower control limit. So to answer part A, Roman 1, I will need mean of, first get mean of means. That is the X with 2 bars is equal to total mean of all samples, then the answer you get divided by, what? Number of samples. Then you do also, after getting that, get mean of range, which is equal to total range of all samples. Then the answer you get divided by number of samples. Okay. So those with the calculator, please you add and tell me. You have mean, simply add all these values, divided by 10. The answer you get divided by 10. What do you get?
30.
That is range, or mean?
Mean.
You're getting what? This one?
I've got 30 here. I don't know whether others also have that.
What about this?
Yes, the mean is 30 and the range is 20.
Okay, that is mean of mean, then this is mean of range. Okay, so from here you can get upper limit, upper control limit for range will be equal to D4 times 20. What is our D4 from the question? Our D4 is 1.777. That is our D4. 1.777 times 20. What do you get? Then our lower control limit for range is equal to D3 times 20, average range, which is equal to D3 is what? D3 is 0.222. Is it 228 or 223? I am not seeing it clearly. 223.
Looks like a 3. Because the first one on A2, I think the last digit is 8. Might be a 3. On the
28. 283.
Yeah, I think like that.
Okay, let me just say 2. Those who are with the question paper, you can copy the right figure. Okay, what do you get?
On the upper control limit for the range, you get 35.54.
35 point?
5.4.
4,
5.4. Then here
4.46.
4.46, 4.5. Okay. You know the reason why I'm doing this is because there is protein. Okay? So don't give yourself too much burden by coming up with many decimal points. So from here, I can also look at, because the question said, Roman 1 said you look for upper control limit and lower control limit for mean and range. Now we have for range, let's also get for mean. Mean, then upper control, this is upper control limit for mean. It will be equal to mean of means is what? 30. Mean of means is 30. Then we add, open bracket, what is A2? A2 is 0.308, which is given here. A2 is 0.308 times the average range, which is 20. What do you get? A lower control limit for mean is equal to, you get 30 minus open bracket 0.308 times 20. What do you get?
Upper control limit.
It is what?
36.16.
36.16. Then
It is
here
36 point.
It is 23.84.
23.84. So that's all about Roman 1. That's all about Roman 1. Roman 2. Roman 2 is about what? Roman 2. Roman 2, we are told to construct a chart, that is range chart. It's always easy. It's always easy. Remember when you're plotting range for plotting purposes, for plotting purposes. Ara chart, Ara chart, you'll be plotting range values against samples. You'll be plotting range values against what? Samples. So on vertical axis, you'll be having range. On horizontal axis, you'll be having samples. On vertical axis, put range. Then on horizontal axis, you put samples. You have 5 samples, isn't it? Are they 5? Are they 5? They are 10, eh? So there are 10 samples from our question. Where is your question? Yeah, we have 10 samples. 10 samples. So if you have 10 samples, it means that on the horizontal axis, you need to use the scale that is going to help you to plot all the samples. That's why here the scale of 2 is being used. We are marking after every 2 centimeter, and I'm using 2 centimeter, rather 2. Every marker represents 2. Marking after every 2 centimeter means that you're marking after 10 small units. So that is a scale. I'm using a scale of 2 on horizontal axis. Then on vertical axis, when you're coming up with a scale on vertical axis, always look at your upper limit and the range values. Then also the lower limit. From our workings, you okay, this time we are given a range direct. We are given a range values direct. So you have range values. These are range values. These are values you want to plot. So you ask yourself, what is the highest value? Here the highest value is 40. The upper limit is what? The upper limit for range is what? Is it above 40?
No, it's 35.5. Actually, yeah, 35.5. It's below 40.
So it means that on vertical axis, the highest figure is only what? The highest figure is only 40. So come up with a scale that can help you to make sure that you plot this 40. Because if you don't come up with a suitable scale, you may end up not plotting some points. So you come up with a scale to help you to plot all the points. So here I'm using a scale of 10. Scale of 10. I think even a scale of 5 can work for you. Can still work for you. Because on vertical axis, since you're not having negatives, you can start from here. You mark down, you leave 10 centimeter down. You leave 10 centimeter down. Then you put you even leave here. On the left side, left of your graph paper, you leave also 10 small units. 10 small units, those are 2 centimeters, then even down you leave 2 centimeters. So you plot, you see this, are you seeing this curve? This curve you're seeing here. These are range values, like on sample 1, this is sample 1. Let me say it is here, sample 1. I stand here, I look for range value on vertical axis. The first range value is what? The first range value is, you stand on sample 1, then you look for the range value on vertical axis. So sample 1, the range value is 23. Sample 2, the range value is 39. So you'll be putting a dot, after you join using your hands. This one you join using a ruler. You join all your points from sample 1 to sample 10. After that, you indicate your upper limit, the average, and the lower limit. These lines you see here. This is the upper limit. Our upper limit was what? It was what?
35.5.
35 point, I think. Yeah, okay. 35, it is around just to know that you come here and see where you have the upper limit, the 35.6. Then you always put a line. Can put even a dotted line, it is also okay. And indicate that that is the upper control limit for range. UCL range, like the way it is written here. Upper control, this is upper control limit for range. This is lower control limit for range. So you can put this line, then you name it as upper control limit for range, which is equal to 35.5. Then after that, you also put your average range, mean range. Our mean range, what was our mean range? Mean of range, it was 20. You put also a line. Then also put a line indicating your lower control limit for range. The lower control limit for range is 4.5. And it is here. And that will be all for your control chart. Put the title control chart for range. And that will be all. Don't forget to put arrows. Put arrow, even here put arrow. To comment, since some values lie outside the upper control limit, you see that upper control limit is you have points that are above upper control limit. So it means that the process is not in control. Since we have some points that are outside the upper control limit, the process is out of control. That is the comment. That is the comment. As long as you realize that there is a point that is outside the upper control limit, as long as there is a point that exceeds the upper control limit, it means that the process will be out of control. Or if you have a point that is below the lower control limit, it will still mean that the process is out of control. But if all points are within, if there is no point outside the upper control limit, or point that exceeds the upper control limit, or point that is below lower control limit, then we say that the process is in the control, or within the control. Okay. And in a situation where the process is outside the out of control, as a company, you have to take some necessary steps to do the right things. You try to figure out what could be the cause and come up with the right measures. So colleagues, that's all with control chart. It is still, even if they ask you mini chart, it is still the same. Just that with mini chart.
If
yes,
I may
please.
ask, what's that line in the middle? The horizontal line in the middle.
The average range, mean of range.
Okay.
Mean of range, this one, mean of range. We have a mean of range, this one.
Okay.
Remember when I was starting, I told you we look at 3 things on the graph. The upper control limit, the average, and the lower control limit. So if you're dealing with mean, then the middle line will be this one.
Okay.
If you're dealing with mean, the middle line will be this one. For range, the middle line will be. If you're doing a mini chart, you base on mean values, not range values. Put here mean, sample mean. You put the word sample mean. Even here you put sample range because you're dealing with samples. So colleagues, that's all. Next time we'll look at proportion chart. Then as we introduce another topic. Isn't it?
Thank you.
Please try other numbers, so that you can appreciate. Time yourself. How many minutes can you take to plot? Time yourself. So do some numbers, the one that we have not done, like model paper. You do like December. You do all the numbers that we have not done.